So a quick overview of how these sessions are going to look like. Normally, we have a brief introduction to the topic, 15 to 20 minutes, covering some of the background knowledge or theory. And then we move on to the practical activity where you live code along with one of the instructors who share their screen and demonstrate your live code for you. You should have done the setup. Unfortunately, because these sessions are very short, we won't have any time available to us to help with setup issues or troubleshooting installation problems. But if you do have an issue, feel free to paste it in the chat. We might be able to help you on the fly. So the person who is not teaching at the moment will try to help you. We are going to be using a shared notes document. You might have seen this document on the chat. You've got loads of useful information at the top. You have access to the slides, to all the training materials. You can come back to this document in the future as well. Feel free to, sign in so we can keep an eye on numbers, please. You can add notes. We might be passing some notes to you or some pieces of code here. If you have any questions, feel free to write them down either here or in the chat. We will be monitoring both documents. And if you want to ever come back to this document, you can, because this will remain available to you after the workshop. And the same goes for the training materials that we are using, so you can come and revisit them if you want to refresh or rejog your memory or come back to your notes. Okay, so let's get cracking with the intermediate Git. So you are probably all familiar with the foundational Git skills. So you've probably already been using Git version control. You have been making changes to your file. Normally we talk about software, but it can be any files that you have under version control. You have been adding files to your staging area, preparing them to be committed. You have been committed changes. You probably have pushed changes to a remote repository, either because you wanted to share them with your collaborators, or if you're working on your own because you wanted to back up your work somewhere on a repository elsewhere. So not just to have one single copy on your machine. You might have been viewing commit history to see what happened in the past. Maybe you have checked out a different commit from your past history. Maybe you have been reverting changes. However, we now want to move a little bit beyond those foundational skills. We want to teach you a little bit more about skills that we use where we collaborate with people in particular. So to enable us to work in parallel with other people on a single project. But also these skills are useful even if you are a solo developer, and we will show you how. But definitely these skills are vital for effective collaboration. If you're working in a team, it will virtually be impossible for you to work without branches, or it will be very inefficient and ineffective. Okay, so maybe your typical development workflow looks a little bit linear. So you might be using a single line of development. So you might be using something which we called, or Git calls by default, a main branch. Maybe you're working on your own, and then you just sequentially commit the changes that you do on a single branch. And that's absolutely fine. But why this cannot be good and what scenario, in which scenarios you might want to actually use a slightly more enhanced development workflow. So think about this. So you have a stable version on your codes, even if you're a solo developer. You have a stable version of your code on the main branch, and locally you're experimenting with some new features of your code. So you've kind of have changes in your local version of your software project. All of a sudden, you're asked to rerun a previous stable version of the code with, for example, with new parameters, or maybe you need to tweak something, you need to generate new set of results. Maybe you published a paper and you need to rerun some analysis with the previous version of your code. Or maybe you're asked to fix immediately a really critical bug in your code, which is unrelated to your current development work. So how would you go about isolating your new changes neatly without losing them? Or maybe having someone else look at your new code and testing it without affecting the main or stable line of development. Now, this is possible. You can, Git has tools for you, and we will cover this, to stash away these changes that you've made to your main branch somewhere else. You can even copy physically the changes that you've done somewhere else on your file system. However, if you have to do this all the time, stashing your changes somewhere else, bringing back an older version of the code to be able to run some experiments, this is not really practical. So while it is possible to always commit on the main branch, it is not ideal, even if you are a solo developer, because sometimes you might want to work on new features, or you want to experiment with your code, and you want to keep your main branch clean and stable for yourself, for your users and collaborators. Now, when you start collaborating with others on a software project, this approach, when you have a single line of development, causes even more problems, even quicker for you, since everyone ends up committing onto the main branch. Everyone keeps interfering with their changes and your changes. You will more often need to resolve conflicts and fix newly introduced bugs all the time, rather than focusing on what it is that you are developing. So normally what we do is we like to create a separate branch, which is often called feature branch, which will then allow yourself and your collaborators to add or test code containing this new feature without affecting each other or the main line of development. So you can work in parallel with colleagues who will be working on other parallel branches without worrying that your code might break something for the rest of the team. And then when you're ready for reviewing your changes and merging them, you can do that safely after you conduct testing and then do a merge or pull request. So how do you decide when to use a new branch? So you should be starting a new branch whenever you're working on a distinct feature, or when you're fixing a specific bug, and that allows you to keep a related set commits in one place without interfering with other parts of the project. Obviously, you can always commit to main, and sometimes when you just have to change maybe one character or maybe one line, you can do that. However, that doesn't give others a chance to have a look at your changes. Okay, so even for a small set of changes that for which you're absolutely sure that are correct and won't break anything, it is always a good idea to put them on a separate branch, have someone else from the team who is not the author of the changes, have a look at them, approve them, and then merge them. So this is considered good software engineering practice. So this kind of work, where you have multiple isolated lines of development, which then potentially can get abandoned if they don't lead to anywhere, or get merged into the main branch of development. This is what we call feature branch workflow. And you have this in Git, and you probably have it in other modern version control systems. So this is not unique to Git. Okay, so what happens when you you're happy with your changes, you've done some testing, and now you want to bring your changes back into the main line of development? Git has something which is called a merge, and it is a process that unifies a work done on two separate branches. So what will happen is that basically there are different merge strategies, as we call, and every merge strategy is suited for a different scenario. And the choice of the strategy depends on the complexity of changes you've done and also the desired outcome. So we are going to cover the theory behind these different types of merges, and then we will get a chance to practice them in our practical part. So the simplest merge strategy is something that is called fast-forward merge. So this is a situation where, which is shown on the left-hand side of my slide, is you have a main line of development. So on the main branch, you have commits A, B, and C. And then from commit C, you've branched off onto your feature branch and you've made some commits on the feature branch. However, the main and the feature branch have not diverged, which means that there are no new commits on the main branch since the feature branch is created. So what happens in this case when you want to merge the feature branch back onto the main branch to incorporate your changes? In this case, Git simply moves the branch pointer of the main branch to the latest commit in the feature branch. The strategy is relatively simple, keeps the commit history linear. So as you can see on the right-hand side of my slide, the history is all in one straight line. So after the merge, commits D and E from the feature branch are in a way merged into the history of commits on the main. At this point, you can delete your feature branch. It doesn't really matter because commits D and E are saved effectively on the main branch. If not told otherwise, Git will by default try to do a fast forward merge whenever possible, but obviously it might change based on your settings. Okay, let's have a look at another situation. So this is a slightly more complicated scenario. When you have the main and feature branch who have diverged, then the fast forward merge is not possible. So if you have a look at the diagram on the left-hand side, what does it mean that the main and feature branch have diverged? Well, that means that since you started your work on the feature branch, someone else or yourself have made another commit to the main branch. So the simple fast forward is not possible. In this scenario, when you try to merge the feature branch onto the main branch, because Git can't do a fast forward, it will try to create, Git will try to do something which is called a three-way merge, and it will generate a merge commit. A merge commit is a special commit that records the combined changes from both branches, and it has two parent commits because it needs to prevent the history of both lines of development, okay? The name three-way merge comes from the fact that Git uses three commits to generate the merge commit. So it uses the common ancestor of both branches, basically, and then the tips of both branches. So if you look at the right-hand side, this is what a three-way merge means. So the merge commit G, which is the merge commit that Git creates after the merge of the feature branch onto the main, actually replays all the changes from the commits D and E, and then it creates another commit on top of it. So basically, you always end up with one extra commit when you're doing three-way merge strategy in Git, and that's just the way it is. There are ways to work around this, and I'll show you how. Well, not really work around, but maybe create a little bit of a better history of commits, which I'll talk to you in a second. Okay, so actually there is a mistake on my slide. It says two-way merge. It's a three-way merge. Apologies for that. I've just noticed that. Okay, so the last strategy that we want to show you is another way to integrate changes from one branch into another, and it's called a rebase. So a rebase solves the same problem as git merge. So both of these commands are designed, both rebase and merge are designed to integrate changes from one branch onto another. They just do it in two different ways. And it's really important to know when to use and when not to use each one. Okay, so if we go back to the previous example from the three-way merge, so you have a situation when you have two branches which have diverged, so you can't do a fast-forward merge. You need to either do a three-way merge or you can choose to do a rebase. So when you rebase the feature branch with your main branch, Git replays each commit from the feature branch on top of all the commits from the main branch in order. So what happens is after the rebase of a feature branch, and if you look at the left-hand side of the diagram, commits D and E that we had on the feature branch, they become commits D prime and E prime, but instead of having the base as commit C, they've been moved and rebased, so the base commit is now F. Now, what happened with these commits D prime and E prime? They are brand new commits, okay? The content of the commit, these commits, is the same as the content of the commits D and E. So all the files that have been changed in these two commits, those changes are replayed, but Git effectively creates new commits with the new SHA identifiers. So effectively it changes the history a little bit, even though the file changes are effectively the same, okay? So now you have a slightly better situation. So you have a situation that is possible to, where it's possible to have a fast forward at this point. So after the rebase, you can do a fast forward and then you get, again, a linear history on main with the commits D prime and E prime replacing the original commits D and E. So the thing with rebase is that it should be used with caution. The first thing that I want to highlight is that where the rebase and merge happen. Now, technically, all branches in Git are equivalent. So there is nothing special about the main branch. It's just convention that Git creates this branch and calls it main. And by convention, we use it maybe for the main line of development. But this branch is nothing special. So all branches are equal. You can merge feature onto main onto feature. The process is the same, and you can do the rebase as well. You can either rebase the feature branch or you can rebase the main branch. Now, the good practice is that you're always rebasing the feature branch, so you're bringing all the changes from the main, replaying them, and then moving all the changes from your feature on top of that rebased commits. With merge, you're typically merging, you're inside the main branch, and you're merging feature branch onto the main branch, okay? And there is also one golden rule of rebasing. So apart from being careful where you are located in which branch when you're doing these operations, with the golden rule of rebasing says that you should never use it, or you should try to avoid using it on a public shared branches. Normally, you will rebase only your local non-shared branches. So you have a feature branch, you've done some development, but the main branch has diverged. There is other work on top of the main branch. What you would do is you would treat rebase as a cleanup tool. So when you are ready for your feature branch to be merged, you will first rebase the main onto your changes. Make sure that there are no conflicts. If there are, sort the conflicts out in your branch and then create a merge or pull request, which then can be followed by a relatively straightforward fast forward merge after someone reviews your changes. Okay, so last thing is what I want to mention is the squash and merge. Okay, so squash and merge command is a command that Git gives us to squash all the commits from a feature branch into a single regular commit. So this is just a normal commit. This is not a three-way merge commit. And you can squash all of these changes. Imagine you've changed loads of files and you tweaked one file maybe 50 times, you've changed some text, or you've added some comments, or you've added some code, and you commit it very often. Sometimes you might have 50 or 40 or 100 commits, or perhaps on a long-running feature branch. So the Git squash and merge enables you to squash all of these 100 changes that you've done into a single commit, and it simplifies the commit history, making it easier to follow. So instead of 100 of smaller changes, you have one bigger change that combines all the changes you've done on your feature branch, and then you can merge that basically branch with a single commit. So it affords you a cleaner main branch history. Your feature branch history will still contain all of these little commits, but the main branch history will be way simpler. Okay, so briefly, the couple of commands that Git gives us, which are really handy for managing local changes. You might have heard of this, you might have used them. First one is git stash, okay, which enables you to save uncommitted local changes in a local stash, and then bringing those changes back when you're ready for them. So imagine working on something, you need to switch back to another branch or another past version of your code. Stash your uncommitted changes, bring them back. That's a very effective tool. There is git cherry pick. Sometimes you want to cherry pick a single commit from another branch without necessarily merging the whole branch. So you can take this specific commit and Git will apply it on top of your current branch. And finally, git reset, which helps you to rewind your commit history. Imagine you've done a commit too soon, happens all the time. Git reset command allows you to undo these commits done locally, okay? If they're pushed to remote repository, then you need to do something else. But if you committed but haven't pushed remotely, it will move your branch pointer back to an earlier commit, and then it will turn those undone changes into uncommitted edits in your working directory. Okay, so with this, we are going to start practicing this Git features, and I'm going to hand over to Aman to take you through the practical activity.
Perfect. Perfect. Thank you, Alex. Hi, folks. Yeah, we'll do some practical activities now. I'll just share my screen and then I can get started. So as I think a few folks here have attended the sessions before that Steve did yesterday and the day before. As you might have seen, these sessions kind of go very packed on time. So we'll follow the same rules that we did in the last two sessions. So the same practices of we won't do a lot of debugging as we go on. We will sort of try to answer the questions in the chat, but please do use the notes document, do use the chat to ask stuff as you need, but that will help us answer in the chat as we're doing the teaching. But on the go, it's difficult to sort of just tackle everything. Okay, I think we can start with the notes first. Let's see. Is my screen visible?
Yes.
Okay. Right. So I'll first give a brief overview of what we'll do today, and then we can get onto the practical. But basically, we'll start with just looking at a template repository. So depending on how folks have interacted with Git and GitHub before, if you've done some basic version control with Git, and if you've used templates. But what we'll try to do is we'll look at all the sort of templating in the GitHub that we've created. We'll copy that repository, and then we'll try to create a pull request, create some issues, create some branches, basically do the different workflows that we were looking at. So Alex explained a lot of the theory behind it and how the merging works, how the commits work. We'll see it in practice on how, when you're collaborating with someone, how they make a change and the pull request might come in. If we get the time, which would be quite towards the end, we'll look at merge conflicts. But as the session goes, we'll see. But to start with, what we will do, okay, wait, I think I might have to just share the document itself. Okay, the example code repository should be visible, I'm assuming. Uh, what we'll do now is we'll look at this example repository and we'll create a local copy of this. So first we'll create a copy on our account and then we'll clone it on our system. So it might have been pasted in the chat. Sorry, I'm just trying to navigate all these tabs. It's difficult to have 10 things on your screen and Zoom cooperate. Yeah, so Alex has pasted the example repository, so the template. Now, what we will do is we'll go to use this template and I'll just zoom in a little. Yeah, and we'll click on create a new repository. So we start with creating a new repository that takes us to this page where we can edit the different sort of aspects of the repository. So let's call it git example. So the same as the template project, and then we choose an owner. So as you can see a drop down of owners. Depends on if you are involved with different organizations in your GitHub. Depends if you only have a personal account, it might just show your name. But if you have different either accounts or different organizations that you are in, it will allow you to choose the owner. And we will keep it public and we don't need to edit anything else here. And we'll just create the repository. So just to quickly mention, so here you can see it says include all branches. So in case sometimes some templates or some, when we do copies of repositories, they can come with different branches as we'll do later. For now, we only have one branch, so we don't need to worry about that aspect. And we will just copy it and it will give us what we need. So again, I'll create the repository and this will take a couple of seconds. Right, so we have this repository, it says generated from universe HPC git example. That means that this is using the exact template that we were looking at. And now what we will do is we will clone this to our local machine. So this is where we look at the terminal. Now I am assuming that people have Git set up on their system. So if Git is all set up on your system and you can do local interactions, this should go fairly smoothly. Let's first see. So I'll do a quick checkpoint about how many people have been able to follow so far. So for both the things, if you have Git set up, if you have Git running, and if you were able to create an example repository in your own account, please give us a green tick. And if not, you can give us a red cross and we'll wait.
Aman, one question. Can you show again how you do a copy of the whole
Yes,
repository?
I'll do that.
Good.
So let me go back. So yeah, just to also point out, it is also in the links that we have on the top of the shared notes. So we see the code repository here. I go to that code repository. Then I say, use this template and create a new repository. While people are giving us the feedback, I'll try to add these notes, but the material is also there, which I'll reshare, where it shows you step by step where you need to go and what you need to do. So we create a new repository. Then this gives us, again, as an example, I can show you. If I now do git example, it shouldn't allow me to create it in my own account because it exists in the account, but I can give it, say, git example 2 as a name, and it should allow me to do that. So I've created this and I see lots of green ticks, no red crosses. I'll wait for another second. So if you have been able to successfully get the example repository, please let us know. And then just to add on, if you have created the example repository and you also have Git installed on your local system, keep the green tick, add the green ticks. But if not, you can change it to either the cross or remove it. Okay. No red crosses. So I'm assuming everyone has their Git setup. Now we can look at the local setup and we can clone this repository to our system. Right. Let's go ahead. I'll quickly reshare my terminal. Okay. So now my terminal should be visible. Let me go back. Now, what we need to do is once you open your terminal, you should have your bash screen. So this can be on whichever OS you're using it. So you can have git bash in Windows as is the recommended setup, or on Mac OS or Linux, it should take you to the default bash. So all of our syntax should be similar. Now, we will type in the commands. What we will do is currently I'm in a folder of my choice in the local system. So this can be any folder for you. It can be your documents, it can be your downloads, wherever you choose to have this repository. So I want it in this folder. So if I do a pwd, that is print working directory, it will show me where my folder is located. So if you do that and you're comfortable with that, we can go ahead. So this is this is where I'll give the command. Now the command for the repository itself will be git clone. And then what we will do is we will get the URL of the repository. Okay, I might just have to share my whole screen because this might take a lot of switches. Let me figure that out. Okay, so now if we go back to the repository and we go to our own template repository, so I'll go to my own account. And here in repositories, I should be able to see the Git example. So what we will do now is we will go to code right here, this tab, this green tab code, and we will clone from the HTTPS HTTPS URL. So you can do this using any other method if you're comfortable with it and if you are comfortable with the setup. But if you don't have the setup, that might restrict you from doing the cloning. So once I have this URL, I copy this and I go back to my terminal and I say git clone, and then I paste that. So this is what we need to do, git clone and whatever your username is. So if it's amangol185, that might differ for you, get example.git. And once I hit enter, it will clone the repository for me. Now, if the repository is successfully cloned, what you should be able to do is you should be able to do cd and then the name of the folder. So cd git example. And once I do this, I should be inside the folder. Now, there are 3 steps here to repeat. First, we open our terminal. We go to a folder where we want to clone the repository locally. And then what we do is we say git clone and paste the URL. And then we cd, we go into that folder. These 3 steps go one after the other. If you are able to execute these steps, please again give us a green tick or let us know in the chat on how that's going. Okay, so we see green ticks so far. I'll give people a minute. And again, if you want to verify that your repository has been cloned successfully, if I do ls, it should give me these 3 outputs. So this is the content of this folder, and it will show me what exists in this folder. Okay, so I don't see any, okay. Alex is answering the questions. Thank you, Steve and Alex. Yeah, if there are any issues, please raise them on the chat as well. But assuming that we are all right at the same point, let's now go back to our code. So I open the Git example repository again. And now what I'll do is I'll go to the climate analysis.py. So this is our Python file. Again, if you've attended the previous two sessions, you might be familiar with this code, where this is the code we were looking at. We were looking at similar code for the Byte-sized RSE sessions, and we'll again examine this, and we'll we'll try to see what needs to be done with this code, how do we improve it, and then use the Git workflow to improve it. So let's look at the code now. Is if everyone is in the GitHub, you can also just look at it locally if you want, but we'll start with GitHub. Now, as you may observe, the code is a little untidy. The spacing is not as consistent as we saw earlier. The parameters, the syntax, it's not as good as it could be. So there are a few errors in this code. Now we will look at these errors and we'll try to first create issues and then look at fixing them slowly so that we can follow the Git practice. So for example, you can notice that there are the hard-coded file paths, which again are not ideal when you're looking at code. We also always want to give relative file paths. Then the function names are capitalized, which are not following the standard naming conventions. The code also has comments. We have the doc strings here. So there are a few things about the code. Now, what we will do is, instead of just correcting it, we will try to open a new issue and point out what the issue is with the code, and then we'll try to tackle it. So for example, if you look at this line 27 of the code, it says far to cells, which is not a function that exists. So that would give us an error if we execute that, because it will it will give us an error that that function is not present. And what we need to do is we need to correct that. We need to match it to the exact code, or we can again correct the typos. We can do a lot of these things. So now let's again go back to the main page. So either if you click on get example or you click on code, it should take you here. And again, this is the main GitHub interface. Here you have the issues and here you have the pull requests. So we go to an issue, that's the tab we select, and we click on new issue. Now in the new issue, we will be given this screen where you can add a title, you can add a description, and then you can create an issue. So let's say we want to add something about the functions. I will add a title about functions should use snake case naming style, right? And we can be more descriptive here. So again, while creating issues, there are no standard guidelines by GitHub or by sort of standard convention, but the usual conventions are you keep it similar to like you do with a commit. So the title itself with issues itself is like the summary, and then you can add in the description what you need. So let's say naming of functions correctly is using capitalization currently. Is using capitalization and needs to follow snake case naming instead. So we do that, and then we can also assign someone. So when you have multiple people on the project, you can see drop down. Right now I click on assign myself, and it will assign me to this issue, and then I'll click on create. So as an overview, what we need to do is we need to first go to our repository. We need to go to the issues tab. Then we click on new issue, and the new issue gives us this interface. You add a title, what the issue is, you add the description, and then you create the issue. If everyone has been able to do that, please, please let us know. Please do the green ticks or a red cross, or again, if you have any doubts, please enter them on the chat. Okay, I see a few green ticks. So I think I'll give people another second. Okay, so now what we'll do is, so we've clarified, we've looked at what the concept of a Git issue is. Now what we can do is we can create, say, 10 such issues for the different issues that exist in the code. So say this is just for the naming of the function itself. Another one was, say, the spacing. Another one was the typo for the calling of the function. You can create those issues and you can tackle them one by one. So you can separate those solutions into branches and then merge them back into the main code. And that's why we use the pull request. So that gives us a very good idea of just separating the code, compartmentalizing it, and also collaborating. So if multiple people are working on the same thing, it's much easier to divide things between issues. So now that we have created an issue, what we'll do is we'll go back to our terminal and let's see. We will now create a branch and we will see how the branches work in Git basically. So let's say Git branch, and that shows us main. So this, if we execute Git branch, it shows us all the branches that we have in our Git repository. So if you're able to execute this, and yeah, it should just show you main unless you created something else, unless you added a new branch, or unless the branches were not cloned properly. So that is again something to keep in mind when you're dealing with repositories with, say, multiple repositories that they're pointing at, multiple collaborators, something this becomes very important. Just the first initial check of branches, because depending on the setting you clone it with, it will sometimes get all the branches, it will sometimes switch to a different branch. So that's something important to keep in mind. Now, this is all the local branches we have right now, but if I do git branch A, this will also show me the remote branches, so the one that are existing on GitHub, and which branch is pointing to which branch, how are these connected? So when I do git branch and I give it the flag -a, what it shows me is that there is a remote. So a remote is the remote version of this Git repository that's on our GitHub account. And it says the origin head, which is the head of this branch, is pointing to origin/main. So now we know that the main branch in origin is also connected to our main branch locally. And that's something, again, you can change. You can point different branches to different sort of commits. You can point them to different name branches. The usual convention is you point the same branches together, you keep the head up to date so that all the code is usually up to date when you're collaborating in big projects. Otherwise, again, this can be an issue sometimes where someone else has updated the code, but you haven't updated your local repository and the heads are mismatched. And then when you try to execute it, Git will refuse to either add your change or merge the commit that you're adding. And this helps us verify that wherever we're looking at in the remote and in the local, that they are in synchronization. Now, to check what our remote is, we can do git remote and give it a -v for verbose. And once we do this, it shows me that this is the remote branch, and this is where it's fetching the code from and pushing the code to. So both fetch and push are the commands that we use. So one is getting things onto the local machine, and the other is to push things from the local machine to the cloud. And both of them point to the same repository as we want it to. So if people are all able to see this, can we do a quick check of green ticks, red crosses, any comments, any questions? Okay, I don't see any red crosses. I'll wait another second. Okay, so another handy command that you might know of is git log. And this shows us that all the commits that we have so far in our Git history. So it shows the initial commit because that's the commit that was made automatically when we copied from the template. So the initial commit shows us that there is the first commit that we made, and as we add commits, it will show up in the Git log. So it shows you all the necessary information. It shows you the commit ID. It shows you which branch it is in, who's the author, what's the date and the time, and all the metadata that you would need to know. You can go into much more detail of this depending on what you're using it for. In GitHub, we can see different interfaces. So the commit hash basically here is the unique hash for that commit. This will be unique all across GitHub to that specific commit. So if you have this code, it cannot, it's basically unique to this commit. It cannot confuse it with anything else on GitHub, on the platform. But again, that is unique to GitHub. That is unique to the Git interfaces we're using. Now, what we'll do is we'll create a new branch and let's try to solve the docstring. Let's try to get started on the docstring issue and solve it by creating a new branch, solve it by getting into that branch and specifically tackling that issue instead of just making the change and directly changing the repository. So if I do, let me clear my screen first and do the clear command, and I'll give people a second. So if everyone gets back on their terminal and we do git branch, and let's say issue right. So we've created this, and now if we do git branch, it should show us that the new branch has been created, but we have not switched to that new branch yet. So if everyone is able to create a new branch and execute this command, okay. Now if added this issue, so this is not the same issue as that we created on GitHub yet, but we've just created a branch here, okay, that I think we should do it right now. I did skip that to save time, but let's say fix doc strings, fix missing doc strings in the code, and I've created another issue, which is again, we'll tackle the doc strings and then we'll use that branch to address this particular issue. So I click on create, it gives us two issues. In a regular session, we would probably do this as an exercise and give you some time. But again, as we are just running it end to end, feel free to create an issue. Feel free to use different issues that you want to tackle. The more important thing here is to understand the branch workflow and not the content of the issue itself. So now that we have our branch, we can again do git branch A. And that again shows you that on the remote, we do not have the new branch yet because we have not added it to the remote. We have not switched to that branch. So we first need to switch to the branch. We can make the changes there. And then we have to push things to the remote to get it all synced up. So this again is an important step because unless we do this, sometimes things can be things can be in different stages. And if you don't know what branch is pointing where, or if you're remote and your local versions are up to date, that can be confusing. That can give you errors that you might not expect. So first, let's switch to our branch. So if I do issue and I click on tab, so again, as we saw in VS Code, if you use VS Code or if you were in Steve's session earlier, you use tab and it will give you the tab completion. And since we only have one branch with the word issue right now, I do the completion. And when I do this, it will take me to the new branch. And so we have created the new branch and we've switched to them. Now I'll wait for people to do that and give me the green text. Or if there's anything that we would like to have a quick look over again, we can do that as well. So I don't see any red crosses. Oh, I think there is a comment. Yeah. Yeah. So difference between git switch and git checkout. So this is an interesting one in the sense that checkout is a more versatile command that can be used for a lot of things. You can use for switching branches, for working directories, for in general sort of creating and then switching. And git switch, I think, was more recent, and that's just purely for switching. So checkout, I think, has been confusing to people before as well, in terms of if you don't really understand, say, the checkout terminology, or you don't want to do anything, say, other than just switching a branch, the git switch is much more friendlier. It would not allow you to do a lot of the other commands that you can do with git checkout. But yeah, there might be other changes. I am only aware of sort of the basic differences. Please feel free to add that to the chat. Okay, I saw a few green ticks and there is no other question or comment. Okay, so let's go ahead. So now what we'll do is we'll go to our code, but this time we're looking at the code locally. So let's open Visual Studio Code and let's look at our code and make changes and then get those changes into our repository. So let me open this again. This is the Git example, that the folder that we want to look at. And once I'm in VS Code, I go to climateanalysis.py. So this is the same code that we have currently on our remote in the main branch, but this is a different branch. So if I open up a terminal, we'll be able to see that. No. Okay, the terminal will take a second. Right. So again, I do not expect a lot of people will be seeing this. This is because I have changed my default terminal, and this gives me just some sort of ease of interface where it shows me which branch I'm currently in. But it might not show you that if you don't have anything on top of your bash. So if I do a git branch, again, it shows me that I am on that branch, and it's highlighting it with a star and in the color. Now, this again is important to note because the terminal, the bash, is coordinated system-wide. Whenever you open a new bash and you're in the same folder, it will use the same git file and will give you the same status. So that is why it's very good with handling all the changes in your system locally. And once you push them online, those changes are synchronized all across. But this can differ if you have two different versions of the repository, if you have two different branches with the same name in different places. So just to be aware that whatever changes you make, as long as you're making it to the same repository, they will be reflected all across your Git ecosystem. Essentially, it uses a Git file, but again, we'll probably not get into the details of that Git file. So let's look at this, and I will, oof, my VS Code has the, I think this is Copilot or something. So now what we've done is I've gone to line 18 and I've started adding a doc string. Now, what a doc string does is helps us document the function, and it helps us also give some more information about the function in a neat way that Python recognizes. So we use three quotation marks, then we give our comments, and then we close it with three quotation marks. So we have said converts Fahrenheit to Kelvin, that's the basic sort of function, that's the basic description of the function. And then we say what the arguments are. So we say, I'll just use autocomplete here. So the basic arguments is far, which is in float. So that's the type of the argument. And then what it represents is the temperature in Fahrenheit. And then we can do what it returns. So the argument accepts and the argument it returns. Now it will return a float and it will return the temperature in Kelvin. That's what we are trying to do. Now we are only looking at this issue. We are not looking at the logic. We're not looking at anything else in this code, but this is what we're adding. I will paste this into the document as well for people's reference. Okay, so I've added this right above the Q&A. Now this is our doc string that we have added to this code. And in modern file editors, it usually saves things on its own, but I'll still do a command S and it's all saved now. Do make sure that you save your changes. If you are again using VS Code, I think it shows like a yellow dot on top sometimes, but it's pretty good at just auto saving as you go now. So now we can add this. Let's say git add climate analysis.py. So what we're doing is we're adding this file to the staging area, and then we'll say what change we've made. So this is how we do the git commit. And again, if we remember from the git basics, we first add something, tell what we are changing, and then we add the information about the commit itself. So we do the git add, and we add this particular file. Now, if I do a git log, it will still show me that only the initial commit is there because you have not committed anything yet. And so a git status again would help us sort of see what's happening. It says that it's modified and this is the file. And then let's say git commit m, and we can say, so this is again pretty flexible. I think I usually stick with like 50 characters for a commit. That's the standard that we use, and like it shows up in all the interfaces without cutting it off. So I say for 2, that is the issue number 2, add missing function docstring. And when I click enter, it will show me what's been changed and it will make it will add the commit to the Git history. So I'll wait for everyone to follow up this far. If you can just react in Zoom, we can basically assess how far people have done so far. Okay, so I see the green text coming in. We'll add another doc string, but we'll try to just sort of, I'll paste the commands, I'll paste the doc string if people want to just use it, but I won't sort of do the step-by-step follow through for that, if that's okay. Okay. So no questions here. Okay. So now what we'll do is we'll just add this doc string to the top of the file where we say performs conversions between, yeah, okay, I'll use the autocomplete. Just a second. Okay, that autocomplete is messing with me. Okay. So yeah, 3 quotations on both sides, and that's what we're adding. I will paste this in the chat. And then we'll again do a quick git add. So I do git add climate analysis.py, and then I say git commit, and then again 2, and add missing module docstring. Okay. So if I clear that and I look at my git log, this is what it should look like. So we've made 2 commits, and those are both our commits. Now I'll give people a second, and assuming that people have been able to make these commits, we can push them. Right. So we do a git push. Now, what we'll do is we need to get our changes from the local machine to the remote. So for that, the command we'll use is git push. Let me clear that. Now I do a git push, and if I hit enter, it will give me this fatal error. And that's what we were talking about earlier, where if the branches are not connected together, because our remote does not know the existence of this branch at all, we have not communicated, we have not pushed anything, it won't allow us to just directly push something randomly. Now it also gives us a helpful suggestion on what we need to do. So it says git push set upstream origin and then the name of the branch. Now, as it might sort of be clear from the command itself, what that will help us do is it will set the upstream. So upstream is the branch that will connect to the origin, and upstream is the command that will help us connect to the branch in the origin. And then we give the name of the branch, and then when we hit enter, it should be able to push correctly. So I'll give a quick minute for everyone to push their code onto their remote. And once we are done, please give us reactions on Zoom, and we can go ahead and look how it looks on GitHub. Okay. So I see a few green ticks. I'll give people another few seconds. So, okay, since we've made the push, what we'll do is we'll go to our GitHub, and if I just reload the repository, it will show me this banner. So I assume everyone would get this banner. Now what this will allow us is to create a pull request, a PR, which helps us merge those changes. So I'll just click on this, compare and pull request. Now, once we do this, again, it's showing us base, which is where we want to merge, and it's showing us compare, which is the incoming change that is being merged. Now, this can be different. If there are, say, 10 branches, I would want to maybe sometimes merge this change with another branch before merging it into main, or whichever my sort of development branch is. We leave this as it is, and it also does a quick check for us, which says able to merge. Now, what we will do is we will just create this pull request, and we will say issue to missing doc strings, and we can add the description. So add missing function and module doc strings. So once I do this, it gives us the description. Now, GitHub is pretty good with automatic sort of automatic detection of the words that we mentioned, so the semantics. So if I say fixes to, what this would also help is it would point to the second PR, the second issue, and it will close the issue once we close this pull request. So if I look at the preview, the #2, the markdown, GitHub will convert into a reference to that issue. So I'll create this, and quick checks again for who has been able to create a pull request. I'll give people a minute. So just to repeat, we were on our code, and what we did was we committed our changes, then we pushed it by setting the upstream. Once we did that, we came to our repository. Any tab you go to, you should be able to see that banner, or you can do it from the pull request itself. And you click on the create pull request banner, and then create the pull request, add some description. I've added that it fixes the second issue as well. And then I clicked on create pull request. So here again, we can see the assignees tab. I am again assigning this to myself. So far, we do not have collaborators, but again, the assignment is very helpful in dividing the work, dividing the responsibilities, and also keeping track on who is collaborating on what parts of, say, a project. And this goes for issues, this goes for pull requests. So you can have multiple assignees as well. So 3 people on one issue, 3 people on one pull request. You can assign people to review as well. So that's another part, which is when you look at reviewers on before merging in a pull request, you would want someone to look at your code apart from yourself. And you can also request reviews from people once you have collaborators on a repository. So I don't see any questions or any cross reactions. Okay. So we have this PR. Now we have created this. Now, just in general, if people have tackled with PRs before, again, these are the main 2 tabs on how you look at the changes for changes in a Git project and a GitHub project. So the issues will give you all the things that people have pointed out. So they don't have to be necessarily fixes. It can be just discussions. It can be just pointing at certain parts of the code and documentation. And the pull requests are essentially the changes that you're making to sometimes address those issues, sometimes not necessarily address those issues, but they both kind of work in tandem. Now, there are interfaces that you can use even from your terminal to tackle these, but it's not always necessary to do that. It's not always I don't think it's standardized. So you can do it using different interfaces. Git has some interfaces. You can have visual interfaces. But again, I think recommendation usually is in terms of Git, purely Git, it's to stick to the terminal because the terminal is quite universal. So even if you don't have access to a graphical interface, you should be able to access the terminal. You should be able to make the requests via the bash. Now with GitHub, it's different because GitHub is a platform which helps us use Git, but it's not synonymous with Git. And GitHub has its own custom solutions. So you have the GitHub command line interfaces, you have the GitHub graphical interfaces. There are a few different things, and these are just like the Git and GitHub interfaces. If you look at these pull requests, if you look at when projects get complex, there can be a lot of branches, a lot of merges together, which again is where, like, say, merge conflicts might arise. There are better tools. So there is, like, I think source tree is one tool that is very popular for looking at different branches and different pull requests and commits together on big projects. So there's a lot of different, yeah, there's a lot of different ways that you can look at these same things. So whatever feels comfortable. But I think, again, the recommendation is to stick with the standard and then move on to the, say, more to the better tool, to the comfortable tool, so that at least if you don't have the if you can't use an additional tool or a feature, you can still stick to the standard. Now, if we go back to this interface and look at this tab, so this banner is basically saying no conflicts with base branch and merging can be performed automatically. So in a usual case, we don't merge our own pull requests. That's not standard practice in collaborative projects. Usually what we do is we would do a review. We would request a review from someone. Now, I'm not sure. Yeah, I don't think it allows us to do self-reviews. That would be weird. It doesn't. That's good. So yeah, usually you request a review, and if I request a review, say from Alex or from Steve, they would get a notification. Then they would be able to approve that change, request a change, or make a comment. I think I should be generally, yeah, so I should be able to just review this. We will look into this. We will look into the reviewing in detail in another session, but they will finish their review. And once that is approved or the changes are requested, then they will approve that, okay, it can be merged, and then you merge the PR. So you generally do not see this by default. But in this case, because we have not set up anything else to sort of conflict with this, we can just merge this pull request. Now, we can also just look at this drop down, and this gives us the different options. So this is what Alex was talking about when we were looking at the different ways to combine branches. So the first one is create a merge commit, where we just create a commit, and all the commits from this branch will be in the base history, and it will show us a merge commit that these branches have been merged. The second is squash and merge, where the two commits that we have, they will be combined into a single commit. And the third is rebase, where the two commits will be rebased and added to the base branch. Now I will click on rebase, and let's see what happens. So if I do rebase and merge, that changes my option here, and this will rebase your changes. Now again, rebase is dependent on the project, if it's standard practice or not, but in a lot of projects, they prefer to have the merge commit. In a lot of projects, they prefer to squash their commits. But just be careful in terms of whatever you change in the Git history, there is a certain level of recursiveness, but there's a certain level of finalness to it, where once, say, you change the Git history, or once you get into the Git history, then you cannot make changes. So we've seen cases where, yeah, I remember when we were learning Git, someone did like a recursive change of squashing everything, and that just basically made it very, very hard to debug that code, because we did not know what happened when, and everything was a single commit, and you just had, say, 10,000 lines of code. Now, that again is dependent on the code, dependent on the project. Sometimes that's what you want, but just be careful of how you merge, how you change, because the last sort of handy tools that Alex mentioned, so cherry picking or rebasing, or just sort of looking at the Git commit, they are very handy, but they're also, again, as I said, they interact with the Git commit history itself. And personally, I think use those tools when absolutely needed. I go to the very basics, and I avoid cherry picking. I avoid just sort of messing with the history, because it scares me. I'll mess up something and Git will just erase everything. So sometimes I just go to the very basics, and then again, later, if I need to, I can squash some commits, I can make the changes once I'm finalized. So now I'll confirm the rebase and merge, and it says your pull request has been closed, you're all set. And it also says that this branch can be deleted successfully. So now that the change is in the main branch, we can successfully also delete the branch. That is, again, dependent on how you want to handle your project. I will leave it be for now. Now, if we go to the issues, now our issue has also closed, because we mentioned it fixes the issue when we reference that PR. So here you would see it says the issue was mentioned, and then issue closed as completed in #3. #3 is the PR. And then we go to the code. And once we go to the code and we look at the commits, now what this did is it basically just added both of our commits without an additional merge commit, or without squashing them together. So this is what rebase did for us, where it just added those commits on the top of what we already had. And that is an example of merging branches. So I think that's time for us.